Today we're going to go over site utilities, and we're going to cover some electric, domestic water, storm, sanitary, natural gas, and we'll go over some hyzers and questions. I know I have a list of the questions that Steve sent out, and got some answers on those as well. So, start off electrical, some design information. We'll have primary electric and your secondary electric. Primary, that's going to be brought in from the utility company, so you need to get on that right away. Usually, we're going to furnish a conduit for them from their pole to the transformer. So, and then secondary, that's going to be from the transformer to the building. Some foot candles, your site lighting. You're going to have inspections. Usually your municipalities are going to require so many foot candles on your parking lots, your sidewalks, and even in your buildings. Retail site lighting, that's a typical grid system, and your poles. And then some other things to think about on electric for the site is where you're going to need power to. Are you going to need, do you have a pump station? If you got a pump station, you're going to need power brought to it. If you got light bollards, you're going to have site lighting around your landscaping, site lighting as far as tall poles. You're going to have to run lighting to each one of those. Monument signs, if you have a big sign up at the entrance to your building or the entrance to your site, if it's illuminated, you're going to need power to it. And then generators as well. So we got some slideshows and some pictures just to show you what some of this typically looks like. Primary conduit here, they're going to come in off the pole. The electric company is. They're going to go underground, and they're going to go to the transformer. So you've got feeder conduit that's runs to your duct bank that's going to feed your transformer and then feed your building. So here's your transformer, and then the wire that's inside of it. So where would you typically set your transformer if you guys had the option to set it? Anybody?
Close to the electrical room.
Close to the electrical room. We want it as close to the electrical room in the building as possible, right? Why is that, Ben?
To reduce the cost of having to run the secondary feeders, which are typically picked up by built by the owner or us and the owner.
Right. So what Ben said, the utility company is they're usually gonna provide their power down their pole and to the transformer. So they're gonna go down the pole around to the transformer. We're gonna provide usually the conduit in there, not all the time, but sometimes we provide just the run for them and a pull string. They'll pull their power all the way through to the transformer. That wire, that cost on them is expensive, the labor is expensive, so we'd rather have the utility company do that. A lot of times they're not going to charge the owner because they're going to be the end users, and they're going to make their money off of the usage of electric. So then we go from the transformer to the building inside the electrical room. What's the value engineering option that we can use when we're pulling that wire? Aluminum versus copper, right? If we can go aluminum, we can save some money. So some things to watch out though on aluminum is check with your elevator. I know we ran into that Candlewood. They don't like that. We were able to talk to them up front and get that worked out to where we were still able to use it. But sometimes they require copper feeds to the building.
Yeah, if you use aluminum, it typically has to be a larger feeder, which might become too burdensome to pull in particular areas.
You're going to hear on site electric, you're going to hear a primary and secondary. So primary from the utility company to the transformers, secondary from the transformer to the building. Some dry utilities, like just conduit, duct banks, maybe that might be on site. If you've got a phone line, where's that coming from? Which, the utility, are they going to come in from the south side of your site, do we need to provide, a conduit for them? If so, we need to locate that, get that installed for them. Typical would be like, telephone, your fiber, your internet, some dry utilities where you just have the actual conduit pulled or set in the ground so that they can come in and run it straight into your IT room. Water services. Some typical things with water, you're gonna have water company requirements, on what forms maybe need to be filled out to get service started there, what they require for the service on site, what they'll allow you to tap into. If they have a big main coming off the street, they might not want you to tap a 24-inch line when they have a 8-inch or 12-inch on the backside of your site. So they might tell you to go the other way. Public versus private. Public is underneath the public roads. It's maintained by the city, the local municipality, or the county. And then private, that's going to be what's on your property, the owner's property, and that's what we would have maintenance on. Whenever you're going to do water, you need to do a flow test. Usually you're going to buy that out with your sub so that they know what the pressure is on that.
Usually you get that free up front. You call somebody like the Charlie United or somebody, or some sprinkler fitters out of town that may be interested in the job. They'll usually go flow it for you for free. So you usually need that information prior to having a sprinkler contractor on board.
What's all included in performing a flow test? Just go out there with like a meter, hook it on the line?
You gotta go to 2 different hydrants. You measure the static, and then you go down and put a flow volume meter on the other hydrant, and you open one up and measure the drop at the other hydrant.
So we had one done for Woodward the other day, and this static was 47 PSI, residual was 45, flowing was 822 gallons. Like, what's the typical range, or like, what does that tell us? Like, those numbers are nice, but I don't know. Like, how do we know if we need a flow test, or how do you know?
You always need a flow test.
Well, I mean, how does it need a fire pump? I mean,
Well, your sprinkler contractor, you can call and talk numbers with him. He can tell you real fast if you got a problem or not. But, you know, it goes back to that 164 divided by 144 is 0.43 PSI for every foot you go up. So it depends on what kind of building you have. If you have a 4-story building, you know, you're going up 60 feet, you can multiply that by 0.43 and know real quick, you're going to lose 25, 30 pounds of pressure as you go up. So if you're starting at 40, you're going to lose 30, you're going to have like 10 on the top floor. So that means you got a problem.
how many do you need?
It's gonna vary by
That's a good question. I don't know exactly how much you need. It depends on the system and your demand and use group, but I can tell you it's more than 10.
Yeah.
You're probably going to need 30 up on your top floor. So don't quote me on that. Maybe you can get away with 20. Again, it depends. And the less pressure you have, you know, it's just a function of it's going to be a little larger pipe. So if even though you may not need a fire pump, it may bump up the cost of your sprinkler system. So those are just conversations you need to have with potential fire protection subs early, just talking through it, just start figuring it out and asking questions, and you'll get to your answers you need pretty quickly. But 40 to 50 PSI is pretty low. You really need 60 and above. Down here in the valley, you have 100 to 110 because you're in the bottoms. But when you get to that pressure, now you got to be thinking about, oh crap, I got too much pressure. What I got to do to reduce it?
The other way.
You know, you might have restraints on your fittings. You may have a pressure reducers in the building, so things like that. But you know, the key always, like something like that, if you don't know, you're not expected to have all the answers and everything, but you should know what resources you have to go to and find out those answers. That's the key.
So you're gonna come in to your site right away, and you're gonna get that flow test done, so you know what your pressures are. And then from there, your utility guy's gonna start bringing in his water lines. For plans and specs, right, we're gonna take it where it needs to go, and we're gonna look at other utilities that are in its area. So water, we have to keep separated from sanitary, so we need to watch those conflicts. It's 10 foot parallel, 18 inches perpendicular. That's a general rule. You need to look at what the requirements are with your local municipality. Some of them might require, if you're crossing under it, that it's encased in a concrete, or a flow fill. I know that's what it was in Fort Leonard Wood. Sometimes it's further than 18 inches if you're crossing under, but it's, or if you're crossing over it, it might be 18 inches. So it could vary there as well.
The big one on the layout that we always see, one of the first things I check is your site light foundations. They'll put those right over the top of your water lines. Happens all the time. And you don't figure it out till you either go to drill it or in the field. So hopefully not before it's too late. Always check that, especially if it's design, build, electrical layout.
Okay. So they're gonna run in off the main, they're gonna have a tap fee as well. Anytime you're gonna tap an existing water line, there's usually a tap fee associated with that. That's one of the things you wanna make sure you pick up in your buyout. Did they include that? How many do they have? If you've got a loop system going around your site, because maybe it's required for the fire protection, or fire hydrants going up. So make sure they have 2 taps, if there's 2 of them. Here's your taps. This is a domestic. He's tapping into the water. Whenever you're doing a domestic tap, look at with your local inspector in your fire department. Who wants to see this? Do they want to see it, the whole process? Sometimes they want to watch it from the start to the finish on the tap, because it's important that no debris gets inside the water line, because they're still pulling off of it for other buildings downstream. Or maybe they just, hey, tap it and we'll come back and look at it when you're done. But know that when you have a domestic tap, you're going to have inspections done on it. Here's a water meter and a vault. They're going to vary in size based on your project. You can have a small little plastic vault box in the ground for your water meter to set in, or you can have a big concrete encased one with your valves on there. A double check detector and backflow. Backflow detector, you're always going to have one of those, and that's to keep debris from getting back into the main water line.
For all these things, it goes back to the same thing as power, but you gotta check with the municipality, because some of them will do their own taps. They don't have the contractor do it, they have their own teams that go out and do it, and they're real picky about whether those meter vaults are in the public right of way or on the private. They'll maybe provide the box for that, maybe provide the meter inside there, so with all of them, call early, but you gotta know what they're gonna provide, because it might be a big difference in the original estimate.
One VE on the water meters. Water meters are priced by the size, so if it's like a 2-inch water meter, a 3-inch water meter, the size goes up. The price goes up as well as the size, which means the size of the vault gets bigger, which means the cost goes up. A lot of times, if you have like a 3-inch domestic line going into your building, you can use a 2-inch water meter. They'll let you step down one size. It's something you can ask your civil, but that's usually the case on those smaller sizes, and it can save you some money.
Also on water meters, I've had it on my last 2 projects here in St. Louis with MSD, where I have a water meter for my building, domestic water, and then I have an irrigation water meter as well. So you could have 2 of those meters and 2 backflow preventers on those as well. And that is so they can determine how much water is going down the storm drain. Because they're going to pay, typically if you just have 1 meter, whatever goes through that meter, the municipality looks at that as that's what's going down their storm drain or their sewer, right? So if it's irrigation, well, that water is not getting drained down there, so you shouldn't get charged for it. So now MSD is allowing us to do 2 meters, so to save the owner some money through maintenance.
The other trick is a sub-meter inside a mechanical room. Then you can deduct the sub-meter off. MSD used to allow that. I'm wanting to say they do not anymore, but maybe you can use that on other municipalities. That way you can take your own readings and prove that to them that that's going to irrigation. But it's really a question you talk to if it's a user of a building. How do you want this irrigation? Some of them want it outside, so the irrigation guys can come touch it any time, make their adjustments. Some want it inside out of the weather, so the controls and everything's in there. Just a good question to ask up front, because it always slips through the cracks on the design side. And you need to know where you're getting your water and electric for it.
Some municipalities are going to charge an extra meter reading fee, some won't. So if there's an extra meter reading fee for the irrigation, if it's $40 a month, well, is it even paying for it to have that in there? So those are discussions that you can have up front when you figure that out with the owner. Some common building materials from the water, you're gonna have cast iron, PVC, domestic, fire service connections. You see all these, those are pretty heavy duty. A lot of things have to be inspected on those. There's seals in there that connect them. Sometimes the local authorities having jurisdiction is gonna wanna see each bend. They're gonna want to make you have some corrosion protection around all your bolts, your lugs that actually tighten down to the pipe. They might have to be wrapped in plastic, thrust blocks on your fire lines. So if you have a loop going around your building for your fire line, the fire hydrants, every time you come up, here's a good example of it, you're gonna have a thrust block at each tee, and then when it's going up as well. You don't always have that concrete curb, or collar on it. Some of them do, some of them don't. That's where you're gonna check again with what's required and also for your plans and specs, what it calls out for. On your fire line, here's your post indicator valve. That's not always required on them. So if it is, you're gonna have something that looks similar to that. And then if you don't have them, you're almost always gonna have an FDC or an RFDC, which is your fire department connection. If it's a fire department connection, it's on the building, right next to it. That's where they're gonna be able to plug in their hoses and pump up the fire protection system. If it's a remote fire department connection, that means it's coming from your mechanical room, it's going outside and it's coming up at a different location. Like Fort Leonard Wood, it was required to be so many feet away from the building. So then they have to have access to it. So that's a good time to get your fire department on site. If they haven't already been there to inspect it, if they're gonna look at all these joints or not, but get your fire department involved early if they don't have a lot of inspections, so you can work with them. So when they do your final inspection, they're happy with everything, you're not getting any surprises. You've had them up front to come look at the below ground, and then when you went into the building, they looked at your riser as you were going up and everything. But work close with your fire department.
Who would drive, like, where all those thrust blocks need to go, or do you just have a mega lock? Like, do you have to have a thrust block every corner, every tee, or justified some locations, like, you're out there just looking?
Your local authority having jurisdiction is gonna really justify where those go and what you require versus if you can do a mega lock. But anytime you're turning up, you're gonna have a truss block. Anytime there's gonna be any significant movement on that pipe, whether it's this way or up or down, you're gonna have a thrust block.
Like at that tee, you potentially wouldn't have to have one?
You would have one here, just because of the pressure going back and forth and the movement that can happen at that joint.
Yeah, there will be, or there should be some specifications that come from whoever the water authority is in that area. Similar with like MSC has their specs, Missouri American Water would have their construction specs that say, you know, per AWWA, you need this many truss blocks or you must use the mega lug here or there. So typically those come back with whatever information we get from the water company in that area.
This is your fire line backflow preventer. If it's outside like that, it's typically warmer climate. If you're doing it up north, it's gonna freeze, you're gonna have issues. That's when it would get moved into a fire riser room or a mechanical room inside the building. If it's inside the building, you're gonna have to work with other things as well to make sure that the fire department has access to that. Storm sewers, typical materials that you're gonna have, your RCP, your reinforced concrete pipes, you got corrugated metal pipes, corrugated plastic pipe, HDPE, some other things. You're gonna have area inlets, head walls, grate inlets, know the different types of inlets that you have out there. Underground detention basins, I've never done one of those, but I know that we have, Brinkman has. You got dry, and wet irrigation, you're gonna have riprap, downstream, leader piping, and then, of course, coordinate your sizing and location with your civil. With
Greater than or equal to 15 feet on the HDPE.
That should have been deleted. I don't know what that is.
Less than, I mean, it's less than.
Right.
15 inches. It's probably supposed to be 15 inches, would be my guess. You usually only see that HDPE on small lines like roof leaders. You don't see it for like large storm pipes.
Most of the time it's, your RCP, a lot of times.
Yeah. That last bullet point on there, is something that you'll learn to do, but the architectural, and if you look at the elevations, they show downspouts and nice straight lines. And then if you go look at a lot of buildings that people build, you'll see the downspout come down, and then it'll jog over 8 inches, and then it'll come down again. Architects and owners pretty much hate that, so match up those two, make sure that they are in the same location, and make sure they make sense, like there's not an electrical box panel on the outside of the building or something like that. They just always end up being messed up.
They are wrong on 95% of the projects.
Yeah.
Storm here in St. Louis, you're gonna deal with MSD. They're gonna require you submit all the drawings to them, your inlet structures, and then they're gonna review that and approve it. You can go from there. They're gonna have an MSD permit as well. So typical when you come in with your storm, MSD is gonna come out, they're gonna do their inspection after you've submitted. Your contractors went and got a permit, for the site based off the plans and specs. He's gonna create a submittal package that goes to MSD, and then MSD is gonna come out on site and do their inspections throughout the process. One thing to look at whenever you're tying in to existing structures, which one way or the other, you're gonna tie in at the beginning or, somewhere along the lines to an existing structure. So you need to have those inspected as well. Make sure that where you're tying in is good. That if that structure is deteriorated and it's gonna fall apart when you get there, it's not gonna be any good. So something you wanna communicate early with the owner, to see what's gonna be required there. If you gotta replace a structure, you're gonna have additional costs. You wanna communicate that early up front with them. It's just some more of the materials. Area inlet, that's typically out in like a grass area, right? It's gonna collect water, and run off from there. Curb and gutter, that's a curb. You're gonna have grate inlets. Grate inlets could be like out in the middle of a parking lot where it slopes to it, so that way people can still drive over them. There is cost differences between those. But you want to make sure that they don't have an area inlet where there should be a grate inlet. Believe it or not, your sub's probably not going to catch that because he's not looking at the asphalt paving, he's looking at his site utilities versus, hey, why am I putting an area inlet in the middle of a parking stall? Some overflow inlets, I'm not going to go through all of these, but riprap, one thing with riprap is make sure that you know that you're putting the right size in. Bigger is not always better, but if it's smaller, it's gonna wash away. So you gotta follow that. The civil engineer's done the calculations on that riprap to make sure that it's sized properly so it'll stay there. So you need to make sure that when your sub comes in and says, hey, I can't get 10-inch riprap, I can only get 8-inch, is that all right? Well, it's not all right. Why? Because it's not plans and specs, and there's a good chance that it won't actually hold what it's supposed to do. So you got to make sure you get with your engineer record.
Back up on that real quick. The other thing is make sure you got the fabric underneath it. otherwise it just washes, the soil underneath washes away. Because you're going in an area of high flow, high concentration of flow there, and it's gonna want to peel the soil out, get it back in there, filling it back in. So you put some fabric or some geofabric under it, you don't have to go back.
Stormwater, pervious pavement. I know Kirkwood requires this, and I know there's a few other municipalities around the St. Louis area that are starting to require pervious pavement. Could be pervious pavement, asphalt, or concrete. There's a lot that goes into these. So there's a typical detail on it, but you're going to have rock, you're going to have an observation well, and then you're going to have your pavement. There's usually a filter fabric at the bottom of it. So some key things to look at when you're doing this is who's got what. Is your excavator, is he going to come in and dig it and lay maybe the filter fabric down in the 2-inch rock, the 2.5-inch clean rock? Or does he just excavate it? And then your concrete, your site concrete guy, is he going to come in and install the concrete, and that's it? Or does he have the rock included? Does he have the filter fabric? Who has your observation well? So I know when I did one in Kirkwood, my excavator, he did the excavation, provided the 2.5-inch clean rock, the filter fabric, and then the pipe and the observation well. And then my site concrete guy, he just had the concrete and curbs. So look at those details when you see them up front and figure out who's got what scope and make sure that you've gone through that intensively.
Well, those can get pretty complicated.
Yeah.
Depends on which project you have and the timing, but that diagram doesn't always do it justice. I mean, some of those are 4 or 5 feet deep. So if you buy the sewer guy just to put the pipe and go away and have your paver come back and add 4 or 5 feet, where's your curb guy go? Does he go before, after? How's he going to set off his pins and things like that? So it gets kind of to be an issue to kind of figure it out and have a lot of meetings to make sense. But in my opinion, majority of that rock's typically by your sewer guy. That way you can go ahead and get it backfilled and in place, and your asphalt guy can come tune it up and place the asphalt.
And I've seen some more complex details where you got this on an angle as well. So then they have, your pavement up here. So they got these built in underneath there, and then you have your rock and everything. So the grading could be a little more difficult as well. But you really got to look at that and see what, like Kendrick said, how it changes.
And you got to think about timing. If you put it in too early, you could silt that basin up during construction. You have to replace it. So you may want to think about wait to the end to hog it out and haul it off. But you also may be short of material on the site or long of material, and you might need that dirt. So
This was just one detail of the 20 details that I had for the small. There were 6 stalls on this project.
And then somebody at MSD went to a conference about pervious paving about 2 years ago, and they've been on that kick for a while. So you'll have it on a lot of projects, which is doable. The main thing is you just need to talk to your owner and make sure he realizes what he's getting. It's a maintenance nightmare. You can't plow it. It fills up with dirt. You got to vacuum it out over time. And there's all these agreements with the MSD that you're going to maintain it. So you just need to have those expectations so he doesn't show up one day and see it.
My
and not have
experience
to deal with it.
Is that I think the asphalt is a little bit more durable than the concrete mix around here, from what I've seen.
You mean pervious asphalt over pervious concrete?
Yes.
Yeah, I can't speak to either. Both of them won't hold up to plowing.
No.
They did it a bunch in Denver a couple years ago, and then they all got torn up. So I think they've gone away from it. But
It seemed like they was able to get a better seal on the smoother surface.
There's ways to achieve the same goals, and bio-retention basins or a bioswale may be a better option on your side. So
that leads into the bio basins. You have dry, underground. There's wet detention basins. Basically, it looks like your dry basin. It's the water's in there. Maybe there's some plants that survive in the water. What we have out here is a wet detention basin. The those are pretty common around here. So I got a detail on this. It's very similar to your pervious pavement as far as make sure you look at who's got what on everything. This is not a real complex system. They can get a little more complex, but ultimately you're gonna have your excavation, you're gonna have some filter fabric, a gravel base. Usually there's a change in size of your aggregate again, up to your sand, and then planting soil topped with mulch, and then your plants on top. You're gonna have a clean out running through there, your pipes running through it. I've seen some where, they call for perforated pipes, and it's gotta be wrapped with filter fabric. This detail doesn't want it wrapped with filter fabric. But all that's gonna go down into, your overflow structure, which then is gonna go into your storm line. The point of these is for water, your runoff water to come in there, set in there, and slowly, filter down through. You know, it's gonna remove contaminants maybe from your parking lot, before it's gonna help treat the storm water before it gets dumped into the system. Once again, with these is when do you put them in? That's a problem. Do you do it early? Do you do it late? Same scenario. If you're too early, the mason's gonna drive right through it with his wool 100 times, and all your rock was just smushed down, and it's gotta be redone. So it's a coordination issue on when you're gonna get that in. Obviously, your site utility guy is in first, so he's gonna wanna run all his pipes. He's gonna wanna come back. So work with that up front, coordinate, know what your sequence is gonna be on that. Sanitary sewers. Just connecting from your existing structures. Again, they're gonna have to be inspected anytime you're getting with the sanitary. You need to make sure that you're not just sending guys down into those manholes. That's a safety issue there because of the gases that are out there. Some things to look for is who's got your surveying on that, who's got the layout of them. You wanna buy that out with your subcontractor, so that way if there's any issues, he's got it. If he set something at the wrong elevation, it's on him, it's not on our surveyor. What kind of backfill is gonna be required on this? Can you use clean rock? Does it have to be in a bed of that crushed aggregate, and then you can put clean rock on top of it, cap it off with soil, or can you just use soil? All those you're gonna find in your specs and your details, and then also what the local age data will allow you to have. There's no clear-cut answer. You can always use clean rock to backfill that. You can't always do it. A lot of time, once you get underneath your building pad or parking or underneath the drive lanes, you can use clean aggregate. So it's just kind of thing you got to look at each plan, each spec, and see what it allows you to do, and go from there. The clean aggregate's nice when you can use it because it's fast. It goes in quick, and they can get a lot done, and then you're closer to home with that. Check your grades on this. You got to have flow right. It doesn't flow uphill unless we got a pump station, so we don't want a pump station. Those are expensive. So always check your grades. Where are you going to typically start on your sewers? Anybody? At the lowest part. At the lowest part, your deepest. You're going to work your way back to your tie-in location. Or to your building. So you're going to start deep and work your way back up. That goes for storm as well. All your utilities are usually going to start at the deepest one. And then amongst those utilities, your storm, your sanitary, your water and your electric, that's the same scenario. You want to start at your deepest one and work your way through those as well.
Explain why.
Why? So if your water line's at 36 inches and it's running from here to there, and you got to come in with your sanitary, and it's going to be 10 feet below finished grade there, you're gonna run the risk of hitting your pipe, plus you're digging out work that you've already done. So you start lower, you're able to stack yourself on top if you're crossing lines. And it's also easier for the excavation, it saves time on them, keeps them moving quicker. Sanitary sewer permits, you're gonna have MSC involved in that as well. Tap fees, we went over that, who's got them, if there are any. Grease inspectors, I haven't done a lot of these, but they, when you do have one, they can vary in size and requirements. So that's something to look at early and upfront, where does it go? Some grease inspectors are outside of the building footprint, and then you could have some inside your building footprint that are catching other, things from like a commercial kitchen. So. Here's some pictures of your sanitary main, a manhole. They're able to use their clean rock there. Ductile iron pipe is also a building material for that. Same with PVC. Here's a stub up right here. This is probably getting into the building or close to the building. This is the clean out. And then here's your branch line. So it's coming from his manhole, branching out. And your tie-ins. Some things to look for on that is, one, the elevation again. We want to make sure we're putting that in the right phase, the sequence. What's our backfill requirements? And then what's testing requirements on that? And who needs to inspect it? Does the local inspector need to look at it? Around here, yeah, they're going to want to see it before it's covered up. Is there any testing requirements on it? The Fort Leonard Wood, we did head pressure. So every time we came up out of the ground, we had to go 10 feet above finished grade, fill it up with water, the whole system, and it had to hold that pressure. Here's the lift station. As I said, typically we flow downhill unless we got to go uphill, then we're going to need a lift station. Whenever you see one of these on site, on your plans, or if you're bidding something, know that the cost is going to go up quite a bit on them. And it's going to depend on the size of the structure. You're going to have pumps in there, so you could have, depending on the horsepower of the pump and how fast it needs to be able to operate. You're going to have power going to it, you're going to have alarms. So that kind of ties back into your side electric. You got a pump station, the lift station, you got to get power to it. Usually you're going to have your regular power plus low voltage, because the alarm probably runs off of low voltage. So you're going to have to route that as well. The grease inceptor, this is just kind of typical detail on how one works, but ultimately you're going to have a flow going into it. It's going to go in, your grease inceptor is going to be two bins kind of like inside. You're going to have one side where it flows into, and the grease is going to separate from there through baffles, and then it'll flow underneath. The water does, because the grease floats to the top, right? And then it goes out into the sanitary line. So after so long, those got to be serviced. They got to clean out the gunk and the grease and get that cleaned up again. But look at the size of them, the footprint. If you have a grease inceptor and it's a huge one out in the middle of a parking lot, because you have runoff and they're required to have it there, how big of excavation is that going to be? How long is that going to take? It can really impact your schedule. So you want to pay close attention to those things. Natural gas or propane, typically around here, natural gas. It's going to come off the main and then come into your building off the main line. You got to look at, if you're involved up front, is in the design phase, where's the gas coming from? Do they have gas close? If there's no gas available, well, you're probably not going to be able to have gas rooftop units. You're going to have to switch over to electric. So those are things that you need to look up front, and if you're involved in the design phase. If you got gas available, then it's usually cheaper for the owner to run the building. If you don't have gas available, you can get with Fleet Gas. They'll give you a map of where it's closest, and they'll let you know if they'll run it to your building for free or not. I know just right across the road on the bank, they didn't have a gas main running from there. The closest one was at the Taubman outlet mall, so they had to come 450 yards down the easement of the road, and then they'll branch off from there and go into our site.
Was that in, like, did they include all that pricing? We didn't have to cover it?
That's a no cost to us, because the owner is gonna be using the gas, they're banking on the consumption of the gas is gonna be high enough that over the time, they're gonna make their money back. If it was a smaller units and they weren't using as much, then yeah, sometimes they'll charge you for it. So it's communication you wanna have up front with them.
How long would an answer like that take to get to a lead? I can't imagine
A couple weeks.
Yeah, you just need to make sure you have all the information they need to determine that. So that's like HVAC plan, anything that's gonna burn gas on site.
Loads, the load requirements for them, how much PSI they need to bring to the site. You gotta have all that information. It's just like with any of these, the electric company, natural gas or water, anytime they need something from you, you gotta act quick. You gotta have a sense of urgency, because you gotta get it back to them as fast as you can. Because if you don't have it to them, they're gonna say, I've been waiting for this for the whole time, that's why your project's not getting water, or that's why you don't have electric on your site. So whenever you do see those, there needs to be a sense of urgency to get that information and get it back to them as quickly as possible. I found around here, like with Fleet Gas, they're pretty great to work with. You get a point of contact, it's usually that same point during the design phase. Then, once you're done with that, he's gonna give you the foreman that's gonna do the installation and schedule it, get that contact information, you just stay in touch with them. Easements, that was one thing I wanted to hit on, is how are they getting to your site? Do they need an easement? If there's already a utility easement along the road, it's a pretty painless process that the police is able to just go through and install. If they're crossing over private property, that's when they gotta, to get to your property, that's when they gotta get an easement done. Your civil engineer usually takes care of coordinating that. I know the bank, that was coordinated by Brinkman, we're taking care of that, because we can push the process faster, and we have that sense of urgency to get it going. Around here, backfill, is that by the GC for the gas that's coming in? They'll do it either way with the fleet. A lot of times, if you provide the rock, they'll push it in. So, and then I just had this happen to me, was boring versus excavation. They came out with both rigs. They asked me which one they wanted to do. No cost increase. I said for it. Right, and they're not tearing up our site. You can't even tell they were there, other than where they had to make their vents. They dug a small pit. So if that's an option, boring's nice and neat. It doesn't disrupt your site as bad. It didn't take them any longer. Actually, it's probably faster. Natural gas, like I said, it's gonna come in off the building, it's gonna come up, it's gonna go into your meter, and then from your meter, it's gonna go into your building, or it's gonna go up your building to your rooftop units, where you supply. One thing to look at with the natural gas is, what's your supply coming in, and what's your meter can hold, and then also, after the meter, sometimes in certain seismic ratings, they're gonna require, like a flex line that goes from the meter through the building. So when we come through here, this might be a flex line, or there might be a flex piece from there to there. That's in case there's any shift, it doesn't just shear off your natural gas. Some of them require sleeves with so much room in them. Fort Leonard Wood, we had like a flex line that had to go in there. So, and for that instance there, our sub said, hey, I don't have that, it's not shown. But as part of their local requirements, they bought them out for local requirements, so they ended up, they had it, right? This is I got a little group exercise we'll go back to here. I want to hit up on these risers. I think we've already hit on it. Roof drains, connections. If you can have the utility guy bring it up right next to the utility, they can save us some time, some money. Sometimes if you're getting the site early and maybe it's broken up and there is a different site developer, a lot of times a phone call, you talk to them, hey, if I give you the location, will you run it to here? And versus just stopping 5 feet out from the building. But in order to do that, you've got to have your surveyor on board and you got to have clear locations of your downspouts, your roof drains. So that way you don't have the issue where it comes down and then kicks over. But if you can do that, that'll save you some money. Existing manholes in the area inlets, getting ready to build a bank in Sunset Hills. And it says reuse existing manhole pending MSD approval. So basically what that's telling me is nobody's looked at these, right? So my buyout question is, what did you provide? So you got new manholes here? If you didn't get new manholes, are you going to be able to use the existing ones? So the engineer of record, he kind of just put a CYA out there to cover everything, and here, we can use it if it's acceptable, if it's a good structure. So look at that when you're looking at your utility drawings. If it says reuse existing, make sure that you're clear on what you have in your scope to the owner. So you would exclude any new manholes on that, or you talk to them and you communicate them, they know exactly what you have there. Natural disasters.
Be careful excluding this, though, Jake. I mean, but if I were you, I'd either get an alternate, see how much it is for the sewer guy, plug it into your bid, just carry the cost. And then if you have to replace it, you write him a change order later, or if it's a real big scope, make an allowance and talk to your owner about it. So, but you just don't want to get into arguing over a change order. It's easier to put the money up front in the deal than try to get a change order in later.
Natural disasters has a huge part to do with site utilities and getting them to our site. They just had a tornado down south of here. Tornado comes through, it messes up everything. Flows over trees, the roots that kick up water lines, takes down telephone poles, transformers needed, generators. So anytime you have a generator on site, you want to get that ordered right away, get that there. Power, if you want to work up front, like I say, get all that coordinated as soon as you can. If a natural disaster comes through and Ameren's sending all of their guys to work nonstop in Kansas City to fix all the issues up there, they're going to stop working on your site. They're going to pull off, and you're no longer a priority. So there's nothing you can do about that other than try to get it in when you have the opportunity. But you have to coordinate that, and then if that would happen, what's the first thing, one of the first things you need to be doing? Anybody? Write a letter.
Notify your owner.
Document. Notify your owner. Hey, we are getting delayed on this project because of this. You want to be clear up front on what's going on your site. No surprises. That makes a nice smooth project, and the owner appreciates that. They might not be happy about it, but they're going to appreciate it. And then throughout the process, you're going to build that great working relationship. So you want to make sure you notify them as soon as possible.
Yeah, pretty much every utility agreement with owners disregard any type of delays. So there's really no recourse there. So you can kick and scream, but utility companies normally don't really care.
And I've never seen it work out good for you to get nasty or rude with a utility provider. That's probably going to hurt you more than it helps you. Unfortunately, that's the nature of our business. You gotta beckon to their every need, and if they need something, you go above and beyond to make sure that their life's easy, and that's gonna get you what you need ahead of time. If Joe down the street is chewing on them, telling them they're the worst utility provider ever, and I'm up there doing whatever he needs, and, to ask him what can I do next for you, he's gonna come help me before he's gonna go help that guy, because they don't have any consequences. They're not gonna get, back charge any money or anything like that.
Couple things on this, when working with utilities like MSD, Laclede, Ameren, normally, once you get past that design phase and there's a cost presented, they don't move without two things, whatever agreement is needed and dollars. So make sure your owners are aware of that, because Laclede or any of them, if they don't get paid, then they're not moving forward with the project. The other thing too is if they are working on your site, they're still required to correspond or coincide with any dig right requirements too. But if it is on a private site, you need to make sure those markings are updated, because dig right locates don't come on the site and locate private utilities typically. They only do public utilities and easements. So that's our responsibility to make sure that those utility companies are aware of anything that's on site, live or not. And then one issue we had with Missouri American Water is, they get so busy that whenever it comes time for a tap, they come to your site, and if your excavation is not safe for them to enter, they'll leave without getting out of the truck. So they're construction workers also, and they're owed the same safety requirements as everyone else. So, typically it's our sub who generates that excavation and makes it ready for them. So we need to make sure that's available, not only for time frame, but also their safety's sake.
Got a Pizer from Main Street, Omaha. Last week we were on site and we were preparing to destroy our detention basin. The landscape drawing shows to use a fescue mix, but on the civil sheets it shows the bioretention soil with plugs. So once again, cross-reference when you do your check set, and make sure you've got your ducks in a row. I don't know how the design team missed that. Pretty blatant mistake.
And if you had to get that inspected by your local jurisdiction, they're gonna want the plugs, because it costs more. That's just how it usually ends up. So if you don't catch that up front, it's gonna cost you money and work to the back end.
Another item, and you may have this coming up, Jake, but the real reason to discuss with your team is when do you want to put these utilities in. I know our intent on the Main Street jobs is always to get these utilities in early so that we don't have to dig back through the base rock or temporary rock that we put down around our buildings. And then typically we use geogrid below that base rock. You don't want to have to dig through that. So you want to effort the utilities early, get them in, get them done.
So these were the questions that came out. Does Brinkman pay for temporary utilities until the building is turned over to the owner? It depends on the project terms, what was agreed upon, or what is called for in the RFP. So on a lot of our negotiated deals, we will carry that cost, or have a budget for that cost. So I would say typically we carry a cost and we pay the utilities while we're in construction, which I know we've talked about it before. Is after you're done with construction, you got substantial completion. That's why it's really important to get those utilities turned over to the owner's name as soon as possible. Small building like my building, bank building's almost 5,000 square feet. It cost me right around $360 for electric, just electric. But imagine if you were, Kyle, do you know what your was in Cincinnati?
Is Bobby in here?
Hotel bill, Marriott, courtyard, was almost $6,000 last month.
So you can see as you get into these bigger buildings, it is not cheap. So if we are carrying that, you know, the project engineer, you communicate, your managers let you know, hey, we got the utilities, you've gone through your cost control, you kind of see what's going on. When you get towards the end of that project, you start figuring out how you get things transferred over. Sometimes it's as simple as calling them up and saying, hey, this needs to go into Midwest Regional Bank's name. Other times, they won't let you change it over. The owner's got to call and they can do it, or there's form work that's got to be filled out. If there's forms that need to be filled out, Brinkley needs to get those packaged up, presented to the owner, so that they don't have anything, they don't have to go and chase down all that information. That helps build that relationship with the owner, make their life easy, right? Build them a great product, and then they're gonna come back to it. Is there any value engineering alternate type over RTP situations where there may not be a lot of heavy machinery or traffic? I haven't had a lot of experience in that. Matt might be able to provide more information on it, but, I mean, there is some value engineering that you could do. You could switch over to like an HDPE pipe. It would be cheaper, material-wise, and it usually installs faster than your reinforced concrete pipe. It's lighter. They can move it around easier. You can usually get it bigger sticks. As you get bigger with concrete pipe, the sticks usually get shorter. So you can cover long runs, but typically I think it's got to be quite a bit of quantity for it to be a good value.
You can get away with PVC also. Based on the breakdown we got from some of our subs on the crossing down in Richmond Heights, they said it wasn't that much of a difference, but you have to think, if you're setting PVC sticks in the ground versus a concrete pipe in the ground, you should be able to move a little quicker with PVC.
Who's telling you what?
Luckily it wasn't, I didn't change all wires.
But there's options there.
Yeah, I mean, always look at HDPE on projects. Now, some municipalities won't allow it. Fallon used not to. I don't know if they do anymore. But it's worth a discussion.
What type of inspection tests need to be performed for the fire domestic water lines? Once again, always reference your specs and what's required and what your local authority having jurisdiction is going to require as well. It could be pressure test as a minimum, because we're going to require that no matter what. So we'll have a pressure test, a flow test, you can get a flushing, there's chlorinate, total coliform, E. coli, the fire department, you know, what do they want to look at? I've talked about it on the fire line where they might want to see each joint. They might want to inspect each lug and make sure that it's got protection on it. You just got to get with those guys up front and know what they want to see and make sure that, you know, you get that there. If you got a big project, it's probably good to have like an inspection board or inspection log so you know what everything needs to be looked at if you're talking to these guys. Share that, communicate that information with your superintendent and your sub.
To go back to Pisers related to fire flow tests, when we were in Colorado Springs, we had to do a full flow test on the hydrants we installed for the fire department. Problem with that is most of it was around finished landscaping. When you open a fire hydrant and just let it flood, you typically have a lot of water. So try and keep that in mind too, of any potential closeout requirements with any authorities having jurisdiction and where those exist as well. They wouldn't let you hose it to someone. They wanted to see it coming out of the hydrant. They wanted to see how much landscape they could distribute. Luckily, it was pretty close to it.
I don't see how much mulch it would hold away.
So if you haven't seen a fire flow test, that water comes gushing out of that pipe. It's moving. It's flushing everything out of there. A lot of times they'll put up a device on there with a piece of metal that'll kick the water down. It also kicks out rocks. If there's rock in the pipe when they installed it, rock comes flying out. You can hear it when it hits that metal pipe. It makes a loud ding. So if you have a job around here and you're getting ready to do one, if you have to do one, and you hear about it, if you've never seen one, go watch it. It's pretty neat to see. Other than the fact, water just gushing out, but at least know what it entails. When is rock backfill required instead of soil? I'd like to be able to give you, hey, we can do it anytime we're in these situations, but each job varies from whether it's in the local requirement or it's your spec requirements. So you got to really just pay attention to that, look at your details, and see what they'll allow. And if the information's not given, you need to go to your engineer record and ask them the question: is this an acceptable backfill?
Rule of thumb is rock is required underneath paving. So if you look at a set of plans and you've got a road or drive lane or parking lot or something like that, and there's a water line that's running 5 feet in off the curb underneath the paving, and you could move that to the green space, generally you could switch from rock backfill over to soil backfill.
How about nyloplast drain basins versus concrete drain basins? Is there a use for one over the other, or requirements?
If you're like a green space, you can look at using nyloplast or some sort of plastic type inlet.
So can you use nyloplast for drive lines, or?
I don't think there's traffic rated.
I don't think they're traffic.
How are large diameter RCP connected? What sealers, equipment's needed? Well, they're usually installed with like a large excavator. You're picking up a lot of weight there, so that's usually the typical piece of equipment they're going to utilize. As far as installation, the large installed the same as the smaller stuff. You're going to clean your joints. You're going to have a gasket. If you can lubricate the gasket, you can put lubrication on it so that it doesn't twist as you slide it together. But ultimately, you're going to have your pipe, your belt, your gasket's going to go in there. You're going to take your other stick, and they're going to slide it in. And that the excavator's going to push that tight together, so you got a good seal. And then they can look down the pipe, make sure that the gasket's not all tore up, and it's got a good seal inside. So typical on that. What is the most important aspect to question during buyout or pre-construction meetings with the utility contractor? I think you heard me say it 100 times, was buyout plans and specs, right? That's the most important. Did you bid plans and specs, and did you also get local requirements? So if they bid the plans and specs and local requirements, they should have everything covered. And then while you're in there, your buyout, just not like everybody, but you want to review what's in their scope. So you don't have gaps. You want to know where they start and stop their work. They have tap fees included, and then spoils. Do they got that? Do they just gonna pile it up one side, or are they gonna haul it all up? So,
in general, with buyouts, it's really the gray areas where you gotta focus. You know, to ask if they got manholes 4, 5, 6, and 7, they're gonna have those. You know, it's not a big deal. It's the spool haul off where they do with the spoils, or that's exactly right. Where do you start and stop? You got a grease interceptor. Who has a sampling manhole? Do you stop? How do you vent the grease interceptor? It's all those type items. And that majority of that's captured on the buyout forms, but it all won't be. So you just have to look through, make sure you have proper check set. But that's for you engineers. It's always that gray area, because that's what comes up in the field. You know, again, like those manhole, that's pretty simple. You got the manhole. That never comes up if I got that or not. It's all the other items. That's kind of how it goes. It's like, and you talk about how the job's going to be built, that there's no surprises. If you get some weird circumstances, or if you have to come in and do it in 2 phases, it's all those type items that you need to cover and buyout. In general, your goal is to have no change orders with that subcontractor throughout that contract. So you just got to think in those terms. What do you need to ask him to get to that point?
So this is technically included under the definition of plans and specs, but soils report, it's worth asking that specific question, because the soils report is what's going to dictate whether they can use rock backfill or dirt backfill. It's going to dictate what their compaction percentages need to be. It's going to dictate how their benching of their trenches is based on the soil type. There's all kinds of things that come into play in the soils report that a contractor could try to say, well, I didn't know it was going to be like that. And if you read the soils report, you should have known it was going to be like that.
Another item to discuss in buyout is pumping of water. simple if you get a rain event, or if you hit groundwater, you want the utility contractor to pick that up. Obviously, if it's excessive rain, then you might have to go to the owner and ask for some reimbursement, but typically, when these guys open an excavation, they need to take care of it and maintain it.
We like to buy it out. If you open it up, you pump it out. So open up what you can get done in one day. When you get a larger job, sometimes that's not feasible, but on some smaller ones, it's very feasible. What is the biggest risk in site utilities? Very spending complex of the site utilities. Like I said, buyout for plant specs, local. But one of the bigger risk is building tie-ins and your basements. Making sure that you've got those covered 100%. And scope gaps, who starts and stops where, making sure that we're picking up everything in between. And unforeseen conditions, which kind of leads to what Matt just hit on with the geo report. If there's, if you got a site that doesn't call for any rock, there's no rock in the borings, and you start going down to dig your storm line and you're hitting solid rock for 300 feet, there's going to be a lot of cost there, and there's a big schedule impact. They got to go get a breaker. Most likely they don't have a rock breaker on site, so they're shut down for that day. It takes 2 days to get a breaker, whatever. It can add up and compound really quick on unforeseen conditions with site utilities, which can really affect your schedule. So that's why it's important to know what's in that geo report.
Yeah, if you're on a site with private utilities or pre-existing private utilities, make sure you kind of identify those with your utility guys and buy out potholing in those areas with those guys, so they don't just go in and rip it out and damage existing utilities that won't be called out by Dig Right or anybody like that.
On Main Street, Lincoln, we're in a private development called the Firethorn. It's like a golf course and a residential development. And they could not locate the sewer main that we were boring underneath. And so we basically sent a letter to our owner that stated if we hit it, it wasn't going to be on us because nobody could locate it for us. So I don't know how far that would have gone had we hit it, but it didn't hurt to send the letter and cover our tail. So
sort of in that line of doing a project, and older cities, a lot of stuff's not called out. You have one call, or like a state rate, that's what they have here. Like they'll miss something, so we hit a concrete whatever in the road and called the water authority back out and said, "What is this?" And they said, "It's not ours. Go ahead and dig it." It was a 60-inch water line. And we hit that, and there was water 150 feet in the air. So
Good video of that.
we didn't have to pay for it because we got a letter saying not our problem.
Even when you know where the utilities are,
Yeah.
even when you know where the utilities are, you're always recommended to go slow around them. Because you never know. I mean, just a jerk of the bucket or something could poke a hole in an 8-inch gas line along 64. Just saying. And theoretically, stuff like that could happen.
There's a lot of horror stories around about finding utilities the wrong way. So,
If you need to locate a utility, we've had a couple situations where we had utilities that we kind of thought we knew where they were. Those like back trucks, they use pressurized water, and they vacuum out the water, and it's like the safest way to excavate around utilities. They're not really expensive to get. They're pretty slick.
and that's what a lot of people are referencing potholing. That's what he's talking about. It's a vacuum truck. It's got looks like a vacuum truck, and then it's got a water line and a big hose about yay big. They put it down on the ground. It uses water pressure, and then it sucks. It makes the hole, sucks it back out, and they haul it off. But they can go down, and once they get down in there, they can even turn it a little bit to kind of expose an area, and you can find what utilities are there, and it doesn't tear up that utility. So.
And Jack, can you go over who calls for locates?
The subcontractors call for their own utility locates. I like to do one myself when I get a project. If we're getting ready to go have the site, if I got time, I'm gonna call one in just so I have one up front. So I know when I'm walking the site, hey, there's some utilities here, to help familiarize myself. But each utility or each contractor that's going to be sticking a shovel in the ground is required to do their own utility location and make those phone calls. That's the risk. You hear Brian talk about it all the time. Our job is to manage our risk. We're putting that risk in their hands. If they hit it, we want them to have to pay for it, not us. If they don't keep up on their markings, if they're gone for a week and somebody ripped out their flag, that's on them, it's not on us. So if we were responsible to do the utility locates and somebody destroyed all the locates and they come to work the next day, they're gonna throw their hands up in the air and say, I can't go, I'm done, no locates are there. And we're gonna just have to eat the cost on that delay. Whereas if it's in their name and they're responsible for it, that's how we bought it out, it's completely up to them. And they gotta protect their own utility locates as well.
Legally, whoever puts the shovel in the ground has to call in the locates. We can't call in the locate for somebody else. Legally, whoever puts the shovel in the ground has to make the call.
With that being said, private, a lot of people probably don't know private utilities versus public are, Jacob.
Yeah.
Maybe explain that a little bit, but, well, I mean, if you call Dig Right or Julie or whatever it is, depending on your state, I mean, they're gonna mark the right of way or the public easements for electrical, sewers, water, but if it's an existing site that has, secondary electric or site lighting or, I mean, there's a number of things. Usually fiber, I would say, would be marked on a public easement, but maybe some private low voltage stuff. That's not gonna be marked, that's on us, that's our responsibility to at least verify that. I don't know if it's legally our responsibility, but we don't wanna hit it either way.
The subcontractor should do that as well.
They should.
That's on them to locate the power lines, the power runs, the home runs to the light poles or to the monument sign or, anything that's under the ground, it's their responsibility to understand what was there and,
Do you think anyone will do it?
they go by,
private stuff?
They go by.
very rarely does anybody do the private side. It's the seat of the pants method. So with that being said, if they hit something, they usually end up paying to fix it.
What Steve said was private versus public. So the public is what is provided by your utility. It's underneath an easement. It's maintenance and its responsibility is by that utility provider. Private is when it's off the easement and it's beyond their gas meter, their water meter, and it's on our site. The owner owns that utility from there on. That's when it becomes private. And that's when you can use potholing to help find that if it's on your site. Because they're gonna come mark out what's in the easement and what's public. And unless they have if they have the information available, they'll mark out what's on the private side as well. But if they don't have that information, the 1-800-DIG-RIGHT might not provide that location because it wasn't available, so.
The other thing is on the QC forms, there is a location for the underground locate number, so that should be on the QC form so that we've actually looked at it to make sure that they called it in and that it is current.
MSD around here, after you're done with the job, you're required to do an MSD as-built. That's when you send a surveyor out there and they survey your clean out locations, your elevations, your flow lines. Everything with storm and sanitary, they do an as-built of it, and that goes back to them, and then that gets put in their system. So MSD, when they have their locates, even on the private side, they usually are able to locate it all because all that information is given to them. So they're strict on the as-built process, but that does help if you're going inside utility location. One of the other questions was, what is the reasoning for tying the entire water lines to make a loop versus just ending at one of the hydrants? They've seen it both ways on jobs. So I've seen this both ways myself. Well, I know that there's benefits to doing a loop around your building, versus going straight out and stopping. It does create a system that allows, the municipality to shut down water in between. If your building's here and you've got a main going here and a loop going around here, if there's any issues in between there, you can shut it down, water still goes around. Ultimately, you've got pressure, going from directions. If it's shut down over here, your main feed is, and there's another main feed over here, it's gonna backtrack through that line and you still got, water available. So, to best answer that question, it's to provide an added insurance on your fire protection lines, so that you'll continue to have water in case of an emergency if there was an issue down or upstream.
The other answer is that the engineer didn't want to call the water company, and so they just threw it all the way around, because they knew they wouldn't kick that back.
That is so. And it could also be a code requirement for it to be a loop system. Fort Leonard Wood, their fire department is extremely picky, and that was their requirement, was it had to be a loop system and tie back in. Any other questions on site utilities?
Yeah, I got one on the as-built plan. So is that something that our sub would go down and take like flow elevations, for instance, with like a total station before they backfill, or how is that actually done in the field? Marking out the elevations of the pipe, so on and so forth.
Well, I buy it out with my surveyor. Sometimes it's the civil engineer already has it included in their scope to the owner. But ultimately, they just go back after it's all done. They pull the lids, pull the caps, and stick their grade rod down there and get their information.
Okay. So they use the cleanouts to find the elevation of the pipes?
Yeah, I mean, yeah.
Cleanouts or manholes? Yeah.
Okay. Sometimes they just need the location of the cleanout, not necessarily the elevation of that cleanout, but they're more particular about the elevation at your manholes.
Okay.
And your inlet structures areas. Any other questions? I think Steve asked everybody to bring unit cost or advisor. So, guess we'll go around the room. Sir?
24-inch RCT with $75 a foot, what I found.
Furnish and install?
Yes. What kind of length? What kind of length?
Yeah, how long?
Like 1,000 feet, 2,000 feet? I think there was like 220 feet.
Is it, what, 24-inch for $75?
Yeah, probably 75. 25.
It used to be a rule of thumb, it was 1.5 times the diameter. And I'm not sure that applies.
It's 1.75.
You
Closer to
got
like 48 inches.
Yeah.
It should be closer to 2. Well, I think it's double.
Yeah, I think it's double nowadays.
Anybody?
I have a Kaiser. I've run into an owner that refuses to get a soils report because they don't want to spend the money. I'm not kidding.
We don't need to work for them.
So, we went ahead and excluded any underground conditions, but I would say if I could do that over again, spend the money, even if it's at our cost, do the soils report, include it in your price, make sure it gets done. Because that job, we had multiple delays on it because of this. Ran into trash pits, borrow pits that were filled with topsoil. I could write a book. So, put it in your pricing and just make sure you get a soils report.
So was that a negotiated job then? On that?
That, yes, kind of. It ended up being negotiated down to a lump sum. So.
Anybody know how much a geotech report costs?
$5 grand.
Yeah, the most expensive actually.
Worth every time.
You'll easily make that up by saving a change order.
I brought up Kaiser, whenever you're doing your site electric or your gas company comes, sometimes they don't have their civil plan, and you would think that the gas company that digs all day, every day would know how to read one. They don't necessarily. They just go 30 inches in the ground or whatever. So make sure that they're doing it per the plan and they're going deep enough, in case you have to dig some out. We ran into an issue with a cleat. The guy didn't even know how to use a laser that was running the job, so. Make sure that,
To go along with that too, if they are boring, you know, at the end of those bores, your pipe sticks up at the end of the ground. So make sure when they go to make a connection at any turn that they're pushing those back down to the elevation they're supposed to be at and not making that connection up closer to the surface. We had an issue in Denver with that where.
Yeah, they should dig a hole and bore into the hole instead of.
Right.
But, and to the edge of what Jared said, the real pipes are there, is you should be rough grade before you have a utility come out and bury their stuff. So if you're not, you can kind of work around it, but you gotta tell them, hey, if we gotta cut 2 feet out of here, you need to dig a little deeper. Or, I mean, there's a little coordination, you can't just let them run.
And in that scenario, if you aren't to grade, then you need to make sure either you're on site or your superintendent's on site while that work's going on, so you, hey, you're not deep enough. Because otherwise, they're gonna go to 30 inches below, and that's where it's gonna lay. Anything else? Unit cost advisors?
I got one. We talk a lot about making sure you understand the water pressure at the street and everything, but, I mean, you kind of hit on it, but the gas pressure too. Generally, if you have a new building and a new feed, right, the gas company's telling you that and you have a pretty good feel for it, but on our renovation in Louisville, the engineer told us we had 2 PSI. We found out after we blew all the regulators that it was 15. And so don't just trust it. It's probably worth the money to test it to really find out whether gas too.
So does that cause a big leak?
No, it didn't. I mean, it held, but
It
we
just
had to
blew
go.
the regulator out.
We had to go replace regulators, and then we had to bring it down to 2 PSI in the basement for the whole building.
3-inch C90 PVC pipe and install about 300 feet, $45.33 unit cost.
We have 8-inch PVC sanitary sewer for like 1,500 feet, for $35.
Yeah, Krista's got a whole page of unit costs that she can send to you from the crossings on the road. Unless you're getting robbed on that 24-inch.
Yeah,
Ours is
no,
49
let's
bucks.
get it was a unit cost of like,
So,
over the bar.
these big utilities, does that unit cost include excavation?
What was that? Yeah, it included excavation.
Looking for everything out there.
Install,
Yes,
stuff,
excavation, bedding,
Turnkey.
piping, and complete backfill to grade, or not?
I asked that question specifically, but,
Typically-
it was line item
Typically,
what
we
it
did
cost.
not, typically, that number does not include backfill in the past, because backfill is a function of what? Not length of your pipe, but depth of your pipe, right? So the sewer lines all vary in depth tremendously. So typically, the unit cost is excavation of the hole and bedding, and the pipe, but doesn't include backfill. The backfill could be rock if it's under pavement, or it could be earth if it's under a field in a green field, and it could be 5 feet, or it could be 18 feet. So just know that when you're estimating that, you can't just grab $35 a foot and say, oh, that's an 8-inch pipe or whatever Chris said. Got it. That's the number, right? There are still variables that apply to that unit cost. It's a big thing, John, like across, it doesn't imagine, if you looked at the whole thing,
Yeah, you will see
yeah, I mean.
tons for.
Yeah, tons and cubic yards, and I mean, it'll be tens, if not hundreds of thousands of dollars in excavation and backfill that have, one variable is the length of it, but the other variable is the depth of it. Keep that in mind.
I got an underground detention basin for about $10 a cubic feet, and it's about a little over 6,000, so.
What kind of detention basin?
Underground detention basin, this is for that Morgantown job.
Okay, so Morgantown was it's like this modular grid poly system There are those types of systems, there are pipe underground detention systems, there are concrete vault box detention systems, so there's a multitude of underground detention systems.
So does that include is that just the system itself, or does that include the dirt on top of it? What all?
So again, typically that unit cost would be
Just that system?
yeah. For underground large box detention, it's usually just the detention box. Because the mass X, because most of those, if it's a big box, is dug by the excavator. So that's a different unit cost, and then backfilled separately, because that's a different unit cost.
Any other unit cost visors?
I got the visors. Coordination, make sure your architectural plans do match your civil plans. If your finished floor elevations are different and your civils are higher, then that's gonna cause you some issues in structure height, sidewalks, and your, drainage. And the way that your site's balanced too, so that was one that got through ours. And then another one is, pre-existing electric service poles. If there are just barely the 10-foot minimum away from your building corner, and it looks good, at the ground, but no one looks up to see that you've got 3 foot of stick off from the pole holding the lines, and then your roof truss tails come out 3 feet, then you're down to 4 feet distance, and,
Yeah, so on the drawings of Town and Country, the power pole looks like it's 10 to 15 feet away from the building corner. However, on site, you have the pole, and then you have the arms that actually hold the wires. Those arms reach out about 3 foot either side, and then along with the truss tails, roof truss tails, those stick out from that building corner about 3 feet. So the distance is deceiving on our drawings versus what actually occurred in the field.
Deceiving.
Right.
It's wrong.
Well, it's not, it's exactly where it was shown.
Problem is, yeah, it's very dangerous to work in close proximity. There's no workaround, there's no shield you can put up to, finish your roof trusses if that happens to you. And if it happens in the middle of November coming into holidays, most of Ameren's staff is senior and they carry 6 weeks vacation a year, and they use most of it during December.
So there's a hazard itself.
Still planning. Another thing you did on there was, checking your civils, to your mechanicals, plumbing drawings, making sure that wherever, they all do the little SU, symbol with your pipe that says C civil drawings, and then the civil drawings say C, mechanical drawing, or plumbing drawings for continuation of pipe. Make sure that those are adding up, lining up, that you're not missing a big scope.
I got something that I don't know if it's technically a pizer, but it's something we did in Wisconsin this year that, the super was fortunately from the north, going into winter. I think it was like $600. We punched in finger drains on all our area inlets in the parking lot, because you're set the final grade, you're above subgrade, you're gonna hold water all winter.
What's a finger drain?
It is a sock pipe, 10 feet long, wrapped around the base. You gotta run it through your local municipality to make sure they're okay with it, but then you create drainage below the plane of the finished pavement. And I was actually surprised the areas where that was at, nothing pumped through the rock we put down, they were all in good shape. South end of the parking lot where there was no area inlet or finger drain, it's all pumped through, and we're gonna have to muck it out, which we knew was coming anyway, but it helps a lot, and they're cheap.
I have one other one, kind of a pizer, but, so, when we did the Central West End project, we were talking about private versus public, and we had to come down an alley, so everything for the site water was private. We had 3 different fire hydrants. City of St. Louis wanted a backflow preventer before each fire hydrant, which Jacob had a picture up there earlier. He said, you can put that above grade if you're in a warm climate. Well, the City of St. Louis doesn't apply. So right, they wanted us to build these hot boxes, is what they called it, over the top of each one of the backflow preventers. Then you had to run power and everything out to each one. So we looked at it a bunch and priced some different options, talked to the city, and we ended up being able to actually come into the building, hit the backflow preventer there, and after the backflow preventer, we teed off and went back outside and then hit all of the fire hydrants. What that forced us to do, though, is then the sprinkler fitters claimed the work instead of the plumbers. So we paid $20-25 more per hour for the guys to go install it inside. So kind of the lesson there is that understand who's going to be installing that, because the plumbers are always cheaper, but sometimes if you have to run if you don't have to have an electrician do something, then maybe the sprinkler fitter is cheaper.
Yes, I have a Pfizer. It's not from sprinkler, but if you're doing a renovation on plumbing, make sure you have the correct drawings from the previous plumber, because sometimes they change things and you don't realize it. They put a Y backwards and stuff was getting caught and clogging the plumbing. We had to run a video down and figure out what was going wrong.
That's a great exclusion on all renovations. Exclude existing piping. Right.
So just a kind of recap on site utilities is we need to understand the full scope of work that you have for your project. Get started early on communicating with your providers on that and coordinate with your subcontractors on schedule, phases, how it's going to go in, and materials that are going to get used, and then create that plan and work that plan. But as you can see, there's a lot of issues as we went around the room with some risers. There was more risers than unit cost, so there's always a lot of issues that come up with utilities. So that's why you want to pay close attention to it, get started on this. Yeah. Tim?
And what depth do I need a ladder and excavation, Jacob?
You don't know that?
4 feet?
And what depth do I need to worry about shoring, trenching, benching?
4 feet? 5 feet.
5 feet. And how?
But 4 feet's a better answer.
4 feet, you can always go above and beyond.
Always go
And then the last number in that you want to remember for the engineer's quiz is, how many, feet is required, or what's maximum number of feet
How far do you have to be for travel?
for an actual egress, for a ladder or an egress?
25 feet. Yeah, winner.
Well, I didn't hear it.
45 feet.
25 feet, there you go. 4 feet for a ladder, 25 feet for egress, no more than 25 feet for egress, 5 feet for benching, shoring, or
So you gotta have a ladder every 25 feet?
You still got that picture, though. You gotta send me that, I gotta put that.
That's going above and beyond.
So, that's all I had. Since you brought up safety so much in your presentation. I had you here.
That's it.